Every day in our life, we do so many activities like walking on the road, jumping, running, writing, kicking the ball on the football ground, throwing the ball in the cricket, hitting the ball with the bat. All these are different activities, but one thing is common, and that is force. Without it, all these activities are not possible. In ancient time also, many people were eager to know that what is this force. Ancestors were believed that all the natural changes happening in the nature like sunset, sunrise, change of seasons are due to force, an invisible force. In 19th century, the father of modern physics, Albert Einstein, also told that the universe is working only because of some invisible force. The Big Bang explosion happened because of the force. So that justifying that all the activities happening because of force only. So today our point of discussion is what is force. Suppose you have a table and a person standing on the floor and he is pulling the table in this direction. Okay, then table moving towards left side. Suppose the same person in another case he just pushing the table, then the table moving the forward direction. You want to open the door, what we do? You pull the door. You want to close the door, what we do? Yes, so you push the door. So in all these examples, we are applying the force actually. Here also applied the force. In this case also have applied the force. In the door example also have applied the force. In all these cases, we have done either pulling or pushing the object. So force is simply defined as push or pull, on a given body. It's a push or pull on a given body, that is force. Now we should know that yes, many types of forces are there in nature, and because of forces, many changes happening to the body. Sometimes body change its state due to application of force. Sometimes body changes shape. Sometimes with the force you can change the speed of the body. Okay, before going to discussion, deep in the discussion of all these changes, first of all we have to know about what is types of force. Basically we have two types of force. One is contact force and second one is non-contact force. Contact, the word tells you that contact means when you want to apply this force, the two bodies should be in contact. Non-contact force means the two bodies should not be in contact, still force is applied. Okay, first comment is contact force. How can we tell a contact force is existing? See me, I am holding a chalk piece. I want to hold the chalk piece and I want to write on the board. If I want to hold the chalk piece, my muscular force are acting to hold this chalk piece. So in this holding condition, my fingers are in contact with this object. So the muscular force, what is making able to hold this chalk piece is contact force. A person walking on the road by holding a suitcase, walking in the forward direction. In that case also, he is in contact with the suitcase and he is holding the suitcase with his muscular force, and muscular force is a contact force. You want to throw a ball, so what we do? You don't throw a ball like this. You stretch your hand in front of you and you throw the ball. So when you're stretching the hand, the muscular force acting on the ball and through which the ball is thrown. So generally the muscular force is generated because of muscular cells in our body. The muscular cells has the ability to stretch and contract. So when you're stretching your hand, the muscular cells will stretch in the hand, the chest, and other parts of the body. The muscular cells will be contracted so that you will be stable, and you can stretch the hand and you throw the ball. So in that way, the muscular force is generated and making the bodies to move or making the bodies to have some change. So that is contact force. Muscular force. Now coming to non-contact force. In non-contact force, the body should not be in contact. Still, the force is applied. Guess what is non-contact force? Maybe you studied in your lower grade, grade 7 or grade 6. Yes, you got it. Now I'll give a small clue to you. What is this? This is North Pole, this is South Pole. So what is called? Yes, this is called a bar magnet. Bar magnet. Now if you keep any iron material like iron nail, when you kept near the bar magnet, what happens? Even the bar magnet not touching the iron nail is attracted towards bar magnet. So without in contact, still it is able to attract the iron nail. So magnetic force here is non-contacting force. Magnetic force is non-contacting force. Now I'll give another example to you. You know that when you drop any object, then what happens? It falls on the ground. Why it is falling on the ground? Everyone knows that because of gravitational force of the earth. Here also, when the body like a ball is falling on the surface, it's falling on the surface because of gravitational force. Gravitational force, and this gravitational force attracting the ball towards the surface. And this surface and the ball is not in contact. So gravitational force is also a non-contact force. After learning contact and non-contacting forces, let us go deep into the contact forces. You know how you are able to hold any object? Ask the question by yourself. See, I am holding the chalk piece again. How am I able to hold the chalk piece? Yes, earlier I told that because of muscular force I can able to hold the chalk piece, but only muscular force, not the reason behind that. There is another force between my fingers and this object making me able to hold the chalk piece. How can I able to write something on the board? Means there is a force between my chalk piece and the board making me to write on it. How are you able to walk on the road? Sometimes you know, suppose if your room floor is made of tiles and it is wet and you wanted to walk on the wet surface, then what will happen? You feel slippery. Sometimes there is a possibility of slip and fall on the floor. Why? At the same time, if you are walking on the road surface, there is no slippery. Happily you can walk. Why? So all these questions, only one answer, I think you got it, and that is friction. So friction. So friction is one type of contact force. So what is more about friction? Because of friction between my fingers and the chalk piece, I am able to hold it. Because of friction between the chalk piece and the board, I am able to write. Sometimes you observe that while we are writing with the chalk piece on the board, you hear some sound, some little high frequency sound, and that sound is also produced because of friction. You are unable to walk on the wet surface, earlier told. You felt slippery and you may fall because of because of water between feet and floor, there is less friction. And because of less friction, you may fall. And you are able to walk on the road, I told, because you have huge amount of friction between your feet and the road surface. That's why you are able to walk. So, in everyday life, what are the things we are doing? Most of the things only because of friction. Somebody asked me, if friction is not existing in nature, then what will happen to the nature? What do you think? Can you do the things what you are doing the things now? Not at all. It is not at all possible. You can't walk, you can't talk, you can't hold, you can't do anything. So everything will be stopped at a time. We all human beings just become like a normal bodies, lifeless bodies. So with friction only everything is possible in the nature. Now what is friction? We have to define the friction. I told that force is pull or push on a given body. Then what is friction? See, there is an object having wheels and this is moving on the surface due to this force F. Moving on the surface of force F. But as the friction is contact force, there is force acting between the wheels and the surface. So, and this friction force always acts opposite to the applied force. When applied force increases, this friction force also increases. So, friction generally opposes the motion of the body. But sometimes you have to clearly understand that sometimes friction supports the motion of the body also. So that's why friction defined as, I'm defining here, it is opposing force which opposes relative motion of the body. See the word relative motion of the body. That means if the body is at rest, because of friction body comes into motion. If the body is in motion, because of friction body comes to stop. See this example once again. This body moving in the forward direction because of force F. And the friction force is increased and we are not at all applying any external force there. Because of friction, after some time the body comes to stop. So here moving body comes to stop because of friction. Take another example. This is the leg of a person and he wanted to walk on the surface or on the road. And you feel that when you are walking on the road, just observe, you are just pushing the road on the backward direction. You are pushing the road in the backward direction so that you are moving in the forward direction. So you are pushing the road in the backward direction like this. So this is your applied force, you are pushing the road backward. Suppose when there is no counter force in the opposite direction, then what happens, because of this force now you fall on the ground. But without falling, what is happening there? There is a counter force, which is a friction between the road surface and your leg. And that counter force balancing your applied force so that this point of contact becomes stable. So that happily you can walk on the road. So in this case, friction supports motion. So that's why I told relative motion. So it opposes relative motion. So when the body is in motion, it comes to stop. When the body is in rest, it supports the body to be in motion. We understand that friction is one contacting force. There is another contacting force also. Let me tell you. There is a ball on the ground, ground surface. And you know that ground is nothing but surface of the earth. And earth always applies gravitational force on the bodies. So because the gravitational force, the ball experiences gravitational force toward the center of the earth, and ball has to go inside the earth, but it's not going. It is stable on the surface. See, I am standing here. I am standing on the floor at the surface. So I should be attracted at the surface. Yes, I am attracted at the gravitational force. So I should go into the earth. Still I am not going. Why? Let me draw the diagram here. So a person standing on the earth surface, and the person is experiencing the gravitational force, GF, gravitational force. Still is not going inside the earth. Why? Because there is another counter force acting, and that force balancing these gravitational forces. And this counter force will be in the upward direction. And this counter force always acts at the point of contact. See this dot careful. This is called point of contact. So this counter force always at the point of contact, and this force always perpendicular to the point of contact, and that force is called normal force. And this is another contact force, normal force. So if you see this case, here also we have normal force at the point of contact. Here you have two legs. So the point of contacts are two. See, this is one point of contact, this is one point of contact. So from this point of contact, a normal force acting upward. From this point of contact, another normal force acting upward. So two normal forces are balancing this gravitational force. So in this case, one normal force supporting the gravitational force. I can say that N equals to gravitational force, GF, implies net force, F net, equals to N minus GF, equal to 0. That means net force acting on this ball is 0. That's why ball is stable on the ground. Here also 2N equal to GF, because why I said 2N, why I add the N, because the two forces are acting the same direction, so you can add up. So 2 plus N, 2N, which is equals to GF. So if you take net force 2N minus GF, which is equals to 0. So net force acting on the person is 0. That's the person is stable. That's why I am stable standing here and teaching you. So normal force is the contact force, always acts at the point of contact in perpendicular direction. Let me write the definition there. It is a contact force acting at point of contact and perpendicular to it. That is normal force. Sometimes you play indoor games. Say, you know the game tug of war, like two groups of people pulling the rope in two different directions, and who crosses the reference line, we declare that that group is the winner group. Like this, there is a rope and persons are standing next to each other by holding the rope in one direction, and in other side also the persons are standing and holding the rope, and these persons are pulling the rope into towards the left side, so towards this direction, F1, and these persons pulling the rope towards the right side, say the force is F2. So they will keep a reference line like this, reference line. So what will happen, to which side of the group will pull the rope such a manner that the other side people will fall, then we say that that side people are winners. So here one thing you have to understand that when the F1 F2 forces both are equal, then they won't move. They are stable because net force acting them is 0. In the previous example, as I told you, when one force is balanced by a counter force, then net force acting on the rope is 0. But when these two groups are pulling the rope with stronger forces, sometimes there's a possibility of breaking of a rope. So breaks. Why? Because there is a certain limit for the rope, and the force exceeds that certain limit. It happens like that. So how could you say that there is a certain limit for the rope? This is based on a particular type of force called tension, and this tension is represented by the symbol T. So here, when these three persons applying the force in this direction, see, left side direction, when they are applying the force in this direction, then there would be another force acting in the rope, by the rope itself, and that force is tension. See, tension exactly opposite to the force and equal to the force. Similarly, coming to this side, when they are applying the force in this direction, then there is a tension acting opposite this force exactly and equal to the force. So that these two tensions are acting in the rope always, and they balance the two forces together. And whenever this force F exceeds the tension, then the rope breaks. Either this force or that force exceeds the tension, breaks happened. So take another example. There is a support, it's a rigid support, okay, and it's a string. The string is connected to a mass, capital M. All of you know that each and every body has got weight. This body also got weight, and this weight acting is a downward direction, and the weight is mg. Weight formula is m into g. We know that. Now, because it's weight, the box M should fall because of the weight, but it's not falling. Why? Yes, you can say that because this string is supporting it. Exactly correct. String is supporting, but inside the string, the tension is supporting that weight. And how it is supporting, It is supporting by acting in the opposite direction. It acts in the opposite direction and it cancels the mg force. Therefore, T equal to mg implies T minus mg equal to 0. So net force acting on the box is 0. That's why the box is stable. So in that way, tension is the force acting in strings and ropes, and it always acts opposite to applied force. See, in this example also tension is acting opposite to applied force. In this example also tension is acting opposite to applied force. So it is a force acts opposite to applied force. Okay, suppose take a rubber band. You are holding the two ends of the rubber band and stretching. Stretch. Means you are applying force in both the sides. But rubber band is not cut in the middle because rubber band is also applying elastic force in the form of tension opposite your force. So it is counterbalancing your applied forces. But after some time, the rubber band breaks because your applied force exceeds the tension or the elastic force of the rubber band. So